ant colonies, really puzzling native features, subtle gaps, unless of course Galena. Nostrils, avocado, Sarah Jessica Parker's eyes, asbestos, Ivan the Terrible, Tiny Titus. All of this is not real. Our universe is most likely a computer simulation. JavaScript can prove it and most likely already have. What and how? Basically, there is a scientific theory that states that our universe, and consequently everything in it, is a computer simulation, which is run by super advanced post-human civilization, or more recently, a drunken cat. Or maybe the guy just stepped out to the bathroom shortly, and Galina, a 60-year-old cleaner from Yugoslavia, who loves nuclear explosions and Corona, has taken over the controls. So, how can we tell that we're in a simulation? Well, there is some empirical evidence that points to it. Here it is. Here it is. Pixels. Pixelated nature of reality. Elementary particles are the building blocks of matter. They are considered to be the smallest units. They are the pixels of physical world. Observer-dependent nature. Quantum mechanics suggests that a particle exists in a superposition until observed or measured. Schrödinger's cat is both alive and dead, unless you've checked. And all of this is like a virtual simulation or a game that requires a programmer or a gamer for events to occur. Quantum entanglement allows for instantaneous correlation between particles, regardless of how far between each other they are. They could be light years apart, but still affecting each other's properties. And nobody knows how this is possible, but it is easily explained by the simulated universe theory. These great distances between the particles are not real, and all locations in simulated reality are equidistant from the central processor. And finally, the speed limits. The maximum speed in our universe is the speed of light. It's constant in nature, 299,792,458 meters per second. Light can't go faster than this. Nothing can. And nobody knows why. But why could be in fact just the speed of this processor that runs the simulation. Had this processor been slower, the speed of light would have been slower. Had it been faster, the speed of light would have also been faster. This is great, but what does JavaScript have to do with all this? Well, experiments could be conducted to prove this theory, and there is a way that JavaScript can help scientists with these experiments. Tiny Titus could be a Lithuanian name. Physicist John Barrow suggests if our universe is a computer simulation, simulators would inevitably encounter computational errors. Despite their advanced understanding of the laws of nature, it could still be incomplete, resulting in subtle gaps or errors. Over time, these flaws would accumulate, leading to glitches in the simulation. Ghosts? UFOs? Crocs? The only solution for the creators would be to patch up problems as they arise, similar to patches in the software. So then simulation laws would occasionally exhibit logical contradictions and breakdowns, perplexing the simulated scientists who would observe slowly changing constants of nature. Scientists could conduct experiments and closely monitor the values of these constants of nature. A simulated universe would contain a lot of bits of information everywhere around us. These bits of information are like blocks of the simulation code, and detecting them would prove the simulation theory. And scientists propose experimental protocol that aims to provide evidence for this idea. But how exactly can JS help with this work and all these experiments? The Zoolander, the Zooniverse. It enables everyone to take part in real-life cutting-edge research in many fields across sciences, humanities, and more. Web-based citizen science projects. Through crowdsourcing and collaborative efforts, JavaScript-powered applications can engage a wide range of individuals in the search of simulated reality signatures. And the sites can have various degrees of gamification and UX and UI extraordinarity that could boost engagement and attract larger amount of participants. And about the origins of the universe. There is a massive project by Stephen Wolfram called Wolfram Physics, which aims to find core, simple, underlying rule to the whole universe. The idea behind this is this: even when the underlying rules are extremely simple, the behavior of the system as a whole can be extremely rich and complex. For example, ant colonies. Individual ants follow simple rules, like following pheromone trails or responding to signals of other ants. However, when you observe the entire colony, you witness very complex behavior, such as coordinated foraging, building intricate nests, and even waging wars with rival colonies. That is why you should always keep an eye on your ant and make sure she doesn't form a colony with other ants. This can be disastrous. Uncle colonies are very rare in nature and do not form that often, and when they do, they are harmless. Another good example would be A Game of Life, created by mathematician John Horton Conway. The Game of Life is played on a grid, where each cell can be either alive or dead. It evolves over time based on simple rules. A live cell with 2 or 3 life neighbors survives, a dead cell with 3 life neighbors becomes alive, and all other cells die or remain dead. Basically, the Wolfram Physics project involves creating a graph-like models of possible universes, as defined by rules that determine how the model evolves. Wolfram and the team are hoping that amateur physicists are interested in helping, such as by running bigger simulations and creating virtual reality visualizers or universe models, and they provide software and programmatic tools on the project's website. But the Wolfram Physics project is not written in JavaScript and does not have an API. And here is why it should. Web compatibility, large developer community, accessibility, fast prototyping. And the universe itself was written in JavaScript. That is according to Lazar Nikolic, a philosopher who has converted to a JavaScript developer. And he has proof in JavaScript you can add variables together that are of different type. And elementary particles in the universe are able to interact with each other even though they do not belong to the same generation of elements. JavaScript is a scripting language, and they are interpreted and not compiled. Similarly, even the most complicated experiments in physics give scientists the results right away. Regardless of the location, JavaScript runs the same everywhere. In no region of cosmos that we know of do certain physical laws fail to apply. JavaScript is also mostly event-driven, unlike Python that responds to function calls. It also responds to calls like but that's a different Python. JavaScript libraries are designed to manipulate the DOM objects. In this comparison, objects are visible and invisible in the universe. JavaScript offers some really puzzling and native features, just like the universe itself. And finally, reason number 7. Just like the universe, JavaScript was created. Just like the universe, JavaScript was created in 7 days. But serious now. It's likely that JavaScript has already proven that we live in a simulated universe. And this is not a joke. And here is how. Here is Mikhail. We're not gonna need him today. Go away, Mikhail. And here is a hypercycle. It describes a set of cyclical chemical reactions which together form self-replicating loops of emergent behaviors. And these self-replicating loops represent a plausible model of origins of life. And this is generated with JavaScript. And here is solar system to scale with Three.js. And here is an infinite procedurally generated universe built with WebGL. And here is how JavaScript can simulate physics. And this is a photorealistic 3D that uses Raytracing right in the browser. And here is a photorealistic WebGL physics simulation of water. And here is a hyperrealistic 3D game built by Alexandre Spindler in 2023. It does not use JavaScript. Thank you very much for watching, like it if you liked it, subscribe, hit the bell, and see you soon. No, in its abilities to create hyperrealistic simulations, JavaScript is definitely moving towards C++, and C++ is definitely moving towards not being able to tell a game from a real life. And all of this is definitely moving towards Lawrence Fishburne offering you medication. There is no spoon, sorry. So with all that exponential rate the technological progress is moving, being able to already create insanely realistic 3D, create AI, simulations of life, flawlessly simulate physics and the laws of nature, all of this is an indication that in the far future humans will be able to simulate the whole universe with all the conscious beings living in it. The simulation argument, and it states that at least one of the following propositions is true. First, human species is very likely to go extinct before reaching the post-human super-advanced state. Second, any post-human civilization will not run any simulations of their evolutionary history, for whatever reason. And third, we are already living in a computer simulation. So basically, if you believe that in the far future humanity would be able to simulate the whole universe, it means that we are already living in a simulation. And judging by the realism of today's computer simulations, it looks like our descendants will indeed be able to simulate the whole universe. Unless, of course, Galina, the cleaner from Yugoslavia, kills us all first. Thank you very much for watching, like it if you liked it, subscribe, hit the bell, and see you soon.